Hello, I'm Tom.
Hello, I'm Tim.
I'm the volunteer coordinator at Storied Brumbo.
I'm a paleontologist who looks after the Fossil Forest Project.
And we've got some questions from the tours from last week and over the weekend. So, Dr. Tim,
Yes, Dr. Tom.
what was the favourite fossil you found?
What's the favourite fossil I found? Oh, well, it's a difficult one because I make no qualms about the fact that I love creepy crawlies. They're my jam, despite being in charge of the fossil forest where there's lots of plants. So I love the little crustaceans that we get here. They're really cool. They are really weird. They look a little bit like tiny shrimp, but they're actually more closely related to the group that woodlice belong to. So they're one of the earliest instances of crustaceans having a go at being like a shrimp or a crayfish. And it's very similar to the meme about how everything becomes a crab. Crustaceans also like to become shrimpy little things as well. I would also say that some of my favourite fossils are the plant fossils that show evidence of the plant interacting with either other plants or the environment. Like we get a lot of the giant horsetails with these weird grooves around them that we think might be strangulation marks from the vines growing up them. So I really like looking at those kind of interactions in fossils. I think they're really interesting.
Yeah, I think I'm going to have to agree with you there. I really like when we find a lovely branching calamites. So the giant horsetails, when we see evidence of them branching and they taper down, they look like little horns. Very cool.
They are cool. Quite rare, but very cool.
Yeah. Okay. Tim, would berries have grown?
I saw this question yesterday, and I won't lie, I lost a bit of sleep about it because it's a really, really good question. So the berries that are around today are it's a colloquial term for a fruit that is encapsulating a seed. So things like blueberries and stuff like that. Although strawberries are a bit weird because they have their seeds on the outside.
Yeah, weird.
So we did have some seed plants back in the Carboniferous. So several groups were producing seeds. One of them is Cordytes, which is the ancestor of modern fir trees and things like that. We do find them, but they're quite rare here. And the other group are the seed ferns, the Pteridosperms. So we have some tree seed ferns, and we also have some climbing vine-like seed ferns. Now, I don't think there's any record of them actually having fruit around their seed.
No.
But I don't see why not. It'd be really cool to find some evidence of a fleshy body around it, because
They'd be soft, wouldn't they? So we wouldn't see them anyway.
The point in these things producing fruit is to make a delicious snack for something to eat, so that animal eats the seed and then travels elsewhere, poops it out, and then spreads the plant. So I wonder if they were doing the same here.
When was the first berry? Something to look into, that.
Something to look into. Excellent question.
Good question. Moving on from that, similar, have you found pollen or spores?
Yes, we have. So the study of pollen and fossil pollen and fossil spores is called palynology. It's a really, really important science. It can tell us loads and loads of cool things about the environment and the distribution of plants and ecosystems. We have loads. So we had a couple of volunteers who have some experience in this science, and they took some samples away, and we found out that pretty much all of the rocks here contain loads and loads and loads of fossil spores. And then very rarely we also find some fossil seeds as well. But yes, we have found plenty of these.
The tricky bit about them is that you can find all these little spores and bits and bobs, but we don't know, well, most of them, we don't know what plant they came from. So it's actually a really tricky science linking that to the plants that they came from.
Yes, and another important point is, the thing about pollen is it's evolved to be distributed, so it carries on the wind. So the pollen and the spores that we find here might not have come from the fossil forest itself. It could have come from other environments further away.
Yeah. Good point. Were there any mushroom forests here? Love this one.
Okay, right. This is a good question, and it's not the first time we've had this kind of question here, and I think it's because there's been a few TV programmes that have featured, what is it, Prototaxis?
Prototaxites, yeah.
Prototaxites, thank you, Tom. So that's the giant kind of columnar fungus that existed, in the Devonian and before?
Just before this period.
Just before the plants got really big. So I don't think we have any of those, because they've been replaced or succeeded by large plants. However, there are fungus in the fossil forest. Under the microscope, you can sometimes see evidence of fossil rhizomes, so the actual kind of rooting networks of fungi, although they're not as prominent in the ecosystem in the Carboniferous as they are today.
Yeah. It would be cool to find one.
Oh, yeah.
Okay, couple more. How do we know our fossil forest is about 314 million years old?
So that's a really, really excellent question, and something we've kind of wrestled with here for a while, because the more precise the claim you make, the more evidence you need to back it up. So saying it's 314 million years old is quite precise.
Yeah.
Now, that number has come from a variety of sources, using different sciences such as biostratigraphy or palinostratigraphy, so using the fossil spores and pollen. And the idea is that you don't have to carbon date or radiometric date every rock you find to get a date on it. What you have to do is find fossils within your rocks that you can find in other rocks that you do know the dates of, and then you can constrain that date finer and finer and finer by looking at other sites until you get a decent date. So that 314 million years old comes from a lot of other studies that have looked at the plants and animals we find here and compared them to other sites where the dates are known. So when we say 314, that's our best guess given all of the data that we've managed to accumulate.
Yeah. Luckily for us, rocks that contain coal, like these ones, have been very well studied because of the coal.
Yeah.
And so we can make those links quite easily.
Yeah.
Okay, last scientific question. How densely could calamites grow? Max number per square metre? That's a question from Canada.
Oh,
Can you believe
nice.
it?
Well, it's like an exam. Maximum number per square metre. I have no idea per square metre. At a guess, I'd say, we see, I'd say 3 or 4 or 5 per square metre.
I think we could be at a point eventually to measure that.
That's a really
using
good
this
point.
site.
Yeah, so once we've uncovered more of the thickets,
A few square metres.
Yeah, we do find all of the calamites growing in clusters on sandbanks in the fossil forest. And they do occur quite densely and in situ, all standing together. So they do represent a colony at a particular point in time. So that is definitely something we can measure, but surprisingly dense, I think.
Yeah,
considering that these things got to about 10 metres tall, they would have been like a bamboo forest.
Yeah, and they all supported each other. That's why they grew in dense little patches.
Yeah, cool.
Okay, finally, Tim, what socks are you wearing today?
Oh, good point. Oh, well, boy.
Oh, no.
I've let the team down.
I think
just black today.
I've got fish.
Fish, right. You're bringing up the side.
I've got a fish.
Thanks, Tom.
And then, Tim, what make are your trousers?
What make are my trousers? Oh, I've forgotten. What are they?
Says there. What's that?
RVRC.
RVRC. I think that's a
They're not
Revolution
sponsored,
Race.
but they're very good trousers to the point where other members of the team are now wearing them.
Yeah, we've got 2 of the members of the team, including myself, with the same brand. So RVRC, if you're watching this, get us a sponsor.
Yeah.
Okay, thanks, Tim.
Thank you. Bye.
Bye.